Hey there, CJ Math students, and welcome to Homework 1.2, Equality and Inequality with Rational Numbers. This is a preview homework. So it says replace each blank circle with a number so that the fractions are equivalent. The word equivalent means equal. All right. So basically we have 1/5, and then what fraction is equivalent or equal to 1/5? Basically in these problems, you're going to want to use your reference sheet. So I have my handy dandy reference sheet right here. I'm looking at my 5s and I'm trying to see, all right, how can I make 5 become 35? Up, there's 35, I multiply it by 7. So I'm going to say, hey, I multiplied both of these times 7, and my answer here is 7. So 7/35, right, is my answer. I want to see this work, what you actually multiplied. Now sometimes it's the opposite. Like in number 2, it's not what did I multiply by, it's what I divide by, or you can think of it backwards. So I can either say what did I divide 15 by to get 5, or say what did I multiply 5 by to get 15. So again, I got my handy dandy reference chart here. I say how did I get 5 become 15? Up, I multiplied by 3. So then I go back here and I said, all right, I did times 3. So times 3 times 3, 2 times 3 is 6. So all we did was just kind of go backwards there. All right, let me skip down to something like number 5. Number 5, how did I get 4 to become 20? I did times 5. So some number times 5 is 45. Now, if you don't know what that number times 5 is to give you 45, you can just do the opposite. So you can find 5, you can go up to 45, and so what number 45 divided by 5 gives you 9? Okay, so this reference sheet is really, really useful to help you find your answer here. Okay, let me skip to something like number 7. So 1 times what gives you 27? Well, obviously it's times 27. 3 times 27 will give me my answer. Now you're saying, oh, 3 times 27, I don't have 27s on my multiplication chart. Well, actually just do the multiplication off to the side. 7 times 3 is 21, carry the 2. 2 times 3 is 6, plus 2 is 81. So 27 over 81 is your answer. So 6 over 15, sorry, always circle your answer, 4 over 9, those are your answer. And finally, number 9, 18 over 24 is the same as what over 4? So how do I get 4 to become 24? Hopefully you say, oh, I do times 6, so times 6. So some number times 6 will give me 18. Again, go to your reference chart, go to 6. Say, all right, I go over to 18. What's the number times that? Up, 3. So 18 divided by 6 is 3. So 3 is your answer here. And it's 3/4. So 3/4 is equivalent to 18 over 24. You're responsible for the rest of them. I should see work just like I do. All right, improper fractions and mixed numbers are two different ways to represent equivalent fractions. All right, so I want you to write each mixed number as an improper fraction. This is a mixed number. When you have a whole number like 8 and a fraction like 3/5, that's a mixed number. So how do we change them into improper fractions? Very simple. It's a couple easy steps. First, you do the whole number times the denominator. So 8 times 5. 8 times 5 is 40, and then you add 3. So 8 times 5 is 40, plus 3 gives you your answer of 43 over 5, and then put it on the answer line. Oops, sorry about that. 43 over 5. Let's do number 14. I should be doing the odds, but oh well. All right. So again, 10 times 3 is 30, and then you add it to 2. So take the whole number times the denominator, add the numerator. 10 times 3 is 30, plus 2 gives you 32, and then you just keep the denominator over 3. 32 over 3. So again, to recap, whole number times the denominator, add it to the numerator. That's how you get your new numerator, and then you just keep the denominator, right? Now, write each improper fraction as a mixed number or whole number. So when you have a numerator that is greater than a denominator, that's an improper fraction. Again, so when the numerator is bigger than the denominator, that's an improper fraction. So how do we do this? We actually divide. We say, all right, how many times does 5 go into 9? All right, 5 goes into 9 one time. You could easily use your reference chart to make sure of that. Say 5. How many times can I go before I get bigger than 9? Up, 10 is bigger than 9, so 5 can go in there one time. That gives me 5. All right, so then 1 times 5 is 5, so I subtract minus 5. Sorry about that again. Minus 5, and I have 4 left over. So this is my answer. my answer is, my whole number is 1, right? Got that from right there. And 4 left over, keep the denominator, 5. 1 and 4/5, right? 5 goes into 9 one time with 4 left over, 1 and 4/5. Let's do 18. So again, 4 goes into 15. Use your reference chart. Let's see, 4 before I get bigger than 15, all right? So I can't go to 16, I go to 12. It goes in there 3 times. So 4 goes in there 3 times. 3 times 4 is 12. And I get 3 left over. So again, my whole number, 3 left over. My whole number is 3. My remainder or leftover, my new numerator is 3, and my denominator stays the same, over 4. So 4 goes into 15 3 times, that's 12, with 3 left over, and you keep the denominator of 4. Right? You're responsible for the odds. Let's go to the back side. All right, so just like we learned today in class, you can compare using less than, right? This is less than, greater than, or equal to. And the way we can do this is we can use the butterfly method. So we can say, what is 2 times 4? 2 times 4 is 8. What is 3 times 3? 3 times 3 is 9. So what's bigger, 8 or 9? And obviously 9 is bigger. You always point at the smaller one. So 2/3 is less than 3/4. And if you think about that, if you were to draw 2 boxes, and yes, I want you to draw these 2 boxes, you can do this visually, right? Divide this one up into thirds, so 1, 2. Divide this one up into fourths, 1, 2, 3, 4. Here's 2/3, and here's 3/4. Which one is bigger? You can see 3/4 is just a little bit bigger than 2/3, right? And that makes sense. 2/3 is less than 3/4, right? Let's do the next one. 3 times 16. Some of you are like, oh, I don't know 3 times 16. Well, you have a reference chart. 3 times 16. So 3 times 16 is 48. So that's 48. And sorry about that. It keeps on doing that. It's 48. And 6 times 8 is also 48. So what do we think it is? It's equal. 3/8 is equal to 6/16. I will do 2 more with you. 5 over 12. Again, use your multiplication chart. That will give you 60. 7 times 8 will give you 56. Which one's bigger? Obviously 60. So 5/8 is greater than 7/12, right? And if you think about this, this 5/8 is only 3 away from being a whole, whereas this 7/12 is 5 away from being a whole. So this one, if I were to say, hey, there's a pizza and you can have 5 slices out of 8, or there's a pizza and you can have 7 slices out of 12, some of you might be like, oh, I want 7 slices. But these are much smaller slices than these 5/8. So this 5/8 is greater than 7/12. I will do 1 more and you will do the rest. 1/7 is obviously just 1 times 7 is 7. And 2 times 6 is 12. So what's bigger? Obviously 12. So 1/2 is less than 6/7, right? Now, using the same logic I just did in number 3, do you want half a pizza or do you want 6 slices of a pizza that's divided into 7? This is going to be a lot more. Half of a pizza, if I draw this box, is just going to be this. 6/7 of a pizza. If I draw the same pizza but divide it into 7 slices. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Yep. So in half a pizza you get this. In 6/7 you get all of this. So obviously you get more than a half, right? You're responsible for the rest. Last one. I'm trying to connect math to real world problems. So number 10, it says answer both A and B. I will do number A. According to the diagram, what percent of the world's population earns less than $10,000? So we'll look at this graph down here and we'll say, all right, what percent of the population earns less than 10,000? So the less than sign is the key thing that we're looking for. We're looking for the less than sign. And here it is, less than 10,000. What percent? gets 68.7% of the world's population. So that's a lot of people earning less than $10,000 a year. That seems kind of messed up. All right, you're responsible for B, and I want you to think about that and think about why we actually go to school. We got these huge problems like inequity when it comes to income, and how hopefully one day you can grow up and address a problem like that. That's it. Call me if you have questions.